Question number 19, that has been drawn from Principle of Communication, and the specialty about this chapter is it's excluded from the JEE Advanced list. So one has to draw a very important conclusion from these all messages that we are getting. Specifically, those areas which are excluded in the JEE Advanced list must be taken care with. All right, it's a AM signal, and on the basis of this signal, you need to write the best equation that characterize this signal. Now say, any AM wave is written in this way: AC plus AM sine omega mt multiplied by sine omega ct. So this is how we move. Now, all you need to do is that you need to calculate the value of omega m, you need to calculate the value of omega c, AC, AM, then you need to fit it here. That's all. But yes, a bit of thought process is involved. First of all, see, if you see this one and this one, so here you could see AC plus AM comes out to be 10, and AC minus AM comes out to be 8. So from this, we can easily calculate that AC would be equals to 9 and AM would be equals to 1. All right, so the first job has been done. How about omega m? You can see that the message signal is, in the envelope of this graph. So omega m can be written as 2 pi by time period, which is 100 microsecond. Likewise, omega c can be written as 2 pi by 8 microsecond, which is self-explanatory in the figure. You got everything? All right, so in that given situation, option number 1 best or exactly suits the given value. Therefore, option number 1 would be the correct one for this. Now it's time we move to the next question. Question number 20, experimental physics, meter bridge. It's so clear here. In the experimental setup of meter bridge, the null point is obtained at a distance of 40 centimeter from A. So initially 40 centimeter here. So let's say the first thing I can write is R1 by R2 would be equals to 40 by 60. So that's going to be 2 by 3. That's the first thing. If a 10 ohm resistor is connected in series with R1, the null point shifts by 10 centimeter. Quite obviously, when this resistance becomes stronger, null point would go there. So this would be 50, this would be 50. Ratio is 1:1. In other words, R1 plus 10 has to be equals to R2, right? So these are the two things that we saw, because when it becomes 50, this would be 50, the value would be equal. Let's try to solve this given thing. So what will I get? R2 is 3 by 2 R1. So I get R1 plus 10 is 3 by 2 R1. And R1 is quite obviously 20 ohm and R2 would obviously be equals to 30 ohm. That's straightforward calculation. Now the question says, the resistance that should be connected in parallel with R1 plus 10. So this would be 30, such that the null point shifts back to its initial position. So let's try to see. Now, how much is the resistance that should be connected in parallel with R1 plus 10? That means 30 ohm. So that will be 30 R by 30 plus R, where R is the resistance to be connected in parallel, and divided by R2. Right? We can easily put that value. R2 is 30. And back to the original, that means this will be 40, this will be 60, so that's 2 by 3. I don't think so. We require any given thing to say beyond it. It's very self-explanatory. Now, you solve this thing and you'll get R as 60 ohm. So option number 1 comes out to be the correct option for this question. Should we move to the next question? Yes. Question number 21, a question related to mixture of electric and magnetic field. So electric field is there, 2I plus 3J, magnetic 4J plus 6K, and a charge Qm is shifted from origin to this given point along a straight path. The magnitude of the total work done, that is to be calculated. Now see, first of all we know that magnetic force does no work, and when it comes to electric force, it does work, but it's really path independent. So it's up to you, what sort of straight line do you imagine? So the question comes something like this. To shift from origin to 1, 1, let me take in this way. Let's say that it goes from origin in this way to 1 and to 1. So this is 1, 1. Starting from here, it goes there. Now let's try to calculate the work done. Work done by electric is only necessary because the magnetic, of course, does zero work. So while it goes along this side, only the x component will do the work. So Q times 2 is the force and displacement is 1. Plus, when it goes this side, only the y component force will do the work. So 3 times Q is the force and the displacement is 1. So that's the total work done. And this gives the total option as 5Q. So this option number 2 is the correct for this question. Time to move to the next question now.